Let's see how to make PMOS common source amplifier with NMOS current source load. So for that, first of all, we are going to create the new project and go to the component, and we need to add PMOS as well as the NMOS. So this is the PMOS, and this is for our the main application, and we need even the NMOS current source load. So for that, go to this one and select the NMOS port. Yes, we'll place this here. And since this is the current source load, we need to supply some voltage to this gate. So for that one, okay, let's add a voltage source here. And we need even the input for our amplifier. So let's say this is the input, and even the VDS. So this is the drain, no, this is the source, this above part, and the source gate and the drain. Okay, so I will just paste this here. So this is the source, this is the gate, and this is the drain, because this is the PMOS, and in NMOS it is drain, gate, and the source. So let's connect now. Okay, so here instead of this resistor or the diode connected load, we replaced that with the current source load. So it ensures that we may get the maximum swing, and even it will slightly changes from this linearity of the circuit. That means little bit the non-linear behavior. So for that, okay, let's connect these things. We'll connect these, and from here to here. So since this the PMOS, this has to be, that means the source has to be grounded. Okay, let's connect these things, and here I need to ground this, and even here we need to ground this, and okay, so let's, okay, now I need to connect these things. So we can see now, and this is for the source, and okay, so this forms the NMOS current source load, and this base has to be connected to the source. So I'm connecting this here. Then even we need to connect from, so here to, okay, from here to here, and from this one we just need to connect to this above. So okay, we'll just name these things. So this is VDS, and I just forgot to connect this one. Okay, let's connect this. Yes, it's connected. And this one is our VGS. Okay, then this one is our VB, or the whatever we are connecting for this one, that we call this as a VB. So now we need to have the PMOS and the NMOS model. So for that, just go to the spice directive and dot model, and here for the NMOS, and here we need to have Kp equals to 200 micro, and VTO equals to 0.4. So I'll just copy these things. So this is for the NMOS, and even we need to have for the PMOS. So for that, this is minus 0.6, and here we need to change from NMOS to PMOS, and here this has to be PMOS. Then okay, we will run this transient behavior and we will see. So okay, I need to give the input. Let's say this will be my input AC signal. I'm going to the sine wave, and minus 1.1. So since this is the PMOS, and the amplitude is let's say 1 m and the frequency will be 2 kilohertz. So this is the 0.48 because we need to answer this is in the saturation region. Okay, so then uh, this one, so it's as usual 1.6 or 1.8 we will take, and this one the ratio, let's say this is a 1 micro and this is 100 micro, and here let's say this is 1 micro and this may be the 20 micro. So now we just need to run this in a transient. We will see how this will going to produce. So stop time is 0, start saving, time to start. Okay, stop time means it has to stop after the 10 milliseconds and step size with 10. So now if you want to see the output, we need to see here. Okay, so here the output is it is not the sine wave. Here we can see the input is a sine wave. Okay, so this is what our input. We need to get it as a sine wave, else we will just increase its tolerance. Okay, so just go to this control panel and go here, the tolerance, just reduce this value. So now, okay, so this is what the input, the sine wave, and when we see the output, so okay, this is not much amplified. Let's change this from 20U to 10U, and we just run this. Now we can see this is from 482 to 489. So we'll just switch back to the no need to change that relay to tolerance. We'll see whether this will going to take for the same. Not here. I just need to go to the control panel, go to the control panel, and here it is 0.0025. Okay, I just missed it. 0.0025. Okay, so now if we run this, then yeah, now we can see it is working for the same thing, but the input wave is yeah, this to the same thing. So this is the input sine wave, that's of a 1 millivolt, and here we are getting the output of so you can see this is get amplified a little bit around, I think it's 12 from, okay, so from 89 to 82 to 89, so it is around 7, okay, 7 milliwatt of gain it got. So now we can see if a small change here, instead of the 10U, if I give the 9U, then the we may not get the proper output. So here these like the L by W or the L and W matters a lot. So that's why we need to make some little bit thorough with setting this L and W for these kinds of circuits. That means the current source load. Here whichever will going to take the first the voltage input, that side the waveform will come. That's why we need to set it exactly. So we can see this one. I think you understood the construction part of the circuit, and a theory is also attached with this. Okay, thank you.